Well, hello. It's me again, coming at you with your next learning target, which is learning target 0.2. I have a new pen collection, as you see over here, and I have a new nail color. So we're good to go. All right, let's get started. Learning target 0.2 says, I can, well, you can't see any of that, can you? I can find the area and perimeter. We're going to do both of basic two-dimensional figures. Okay, and the basic figures they refer to in this learning target are the following. We are going to talk about triangles. We are going to talk about squares. We are going to talk about rectangles. And we are going to talk about parallelograms. Okay? Now, triangles are three-sided polygons where squares, rectangles, and parallelograms are all four-sided polygons, which we call quadrilaterals. So these are specific types of quadrilaterals that we're going to deal with here. And the geometry world refers to these as our basic two-dimensional shapes. So let's start with perimeter. Perimeter is basically the distance around a figure. So when you're looking for the perimeter, it's like putting a fence around a shape. So we really don't need to get into a lot of formulas for perimeter, because what do you do when you find perimeter of a triangle? You add up the three sides. What do you do when you find the perimeter of a square? You add up the four sides. Now with a square, all four sides are the same. So you could add the four sides, or you could do a single side and multiply it by 4. Okay, rectangle, four sides again, so you'd add the four sides together, same with a parallelogram. Now they have some little tricky things to do there as well, and we'll talk about them when we get to them. So let's look at triangle first. Okay, so for a triangle, we have three different sides. For the perimeter, we would just add the three sides together, A plus B plus C. Sometimes the three sides will be the same, sometimes they won't. But whatever the three sides are, we are going to add them together. This plus this plus this will give us perimeter. For a square, now a square is a unique quadrilateral. A square, we'll get into this more later in the year, all four sides are the same, as I'm showing you with my congruence marks. And just for an added bonus, I'll tell you they have four right angles. So this is an equiangular equilateral quadrilateral, which makes it regular. So when we find the perimeter of a square, we could just say that's side plus side plus side plus side, or since we know all four sides are the same, we could say perimeter equals 4 times S. Okay? Which is what you get if you add S plus S plus S plus S. Don't you get 4S? Yes, you do. All right, let's look at a rectangle next. For a rectangle, again, you would add the four sides together. Okay? Now with a rectangle, opposite sides are congruent. So we are going to add the four sides together, but these two will always be the same, and these two will always be the same. So if we call this side the width and this side the length, we could say we have length plus length, because these two are the same, yes, plus W, which is the same as 2 of the L's plus 2 of the W's. 2 times L plus 2 times W for perimeter. Okay? Lastly, for parallelogram, let me see if I can find that on my handy dandy template. Why can't I see parallelogram? There it is. Actually, a rectangle and a square are both types of parallelograms, but again, we'll get into that at a later date. For parallelograms, well, let me back up to rectangles. They also have 4 right angles, so I want to make sure you know that. For a parallelogram, opposite sides are still congruent, okay? So if we call this side, let's call this side C, and this side length D, then we could say the perimeter of a parallelogram would be C plus C, because these two are the same, plus D, or we could say that's 2 times C plus 2 times D. I don't really care how you get there. If you want to, for squares, if you want to say 5 plus 5 plus 5 plus 5 is 20, and the person next to you wants to say 5 times 4 is 20, you're both getting to 20, I'm good with that. So I don't really care how you get to perimeter, but I need you to understand the concept of perimeter, which is putting a fence around a shape. It has nothing to do with what's inside. It has to do with the exterior sides. So this plus this plus this plus this. Literally, like, there go the lights again. I did request to have those fixed for the 3rd time, so maybe we'll get there soon. So perimeter is like putting a fence around a figure, okay? Let's pause there for a question on perimeter. Okay, we're back. Next, let's talk about area. Area is a little more tricky than perimeter. Again, perimeter is the distance around. Let's talk about units on perimeter. So units for perimeter before we get to area. Units for perimeter are things that you would measure with. So feet, inches, yards, kilometers, centimeters, miles, and so on. Okay? Those are units for perimeter. If the figure doesn't give you units, then you would just say unit. So if this square had sides that just said 5, 5, 5, and 5, and we didn't know if that was 5 meters or 5 kilometers or 5 feet, then we would say, okay, the perimeter of this square is 20 units. Okay, if we don't know what the unit is, we just call it unit. All right, moving on to area next. Area is a little bit trickier. I'm going to switch colors because I can. Let's go to pink now for area. So the area of a triangle is going to be the base times the height divided by 2. All right, so let's pause there and talk about what does that mean. Okay, what is a base? What is a height? Well, height is the trickiest part. For height forms a right angle with the base. Okay, so I guess the question would be, how do you know which side is the base? Well, the base is the side that forms a right angle with the height. So here's your height, here's your base. Okay, we'll do examples on this in a minute. Sometimes the height is outside of the triangle. So let me show you kind of a trickier situation here. So here is a weird looking triangle, not your usual look to a triangle. So for this one, it'd be easy to find the perimeter. We would just add these 3 sides together. But if we wanted to find the area, we have to have a right angle formed with the base. So we would have something like this in our picture. You would not have to come up with this on your own. This would be in your picture. Do you see how it has a right angle there? So the right angle tells you that this would be the height, but this would be the base. We would not count this part as the base. That's sort of our work. That's not part of the triangle. The turquoise is the triangle itself. The base has to be one of the sides of the triangle. And since the height forms a right angle with this side, then we call this side the base. And so we would do base times height divided by 2. Hang on one second, I'm dropping the plate. Okay, so I know this is tricky, but we're gonna get good at this before we're done. Let's get our notes done and then we'll just do a bunch of examples. For squares, the area, actually for squares, rectangles, and parallelograms, quite honestly, the area is simply going to be base times height. Okay, when I don't put anything between the two letters, that's multiplication. The area equals base times height. Area equals base times height. Well, with squares and rectangles, it's easy to figure out where the right angles are because all four angles are right angles. Okay, so it doesn't matter, let's say for this square here, it doesn't matter if we call this side the base or this side the height. We could also call this side the base and this side the height, because this forms a right angle with this side and this forms a right angle with this side. So in these two examples over here, base and height are interchangeable. And again, we'll get to more examples, well, any examples after this, and we'll talk about it. Okay? Lastly, for parallelograms, area equals base times height once again. This one's a little trickier because we don't have our built-in right angles. So once again, you would have to have the height drawn in for you by me or by the book or whatever resource we use. And so if this is the height, then that would tell you the side that the height forms a right angle to is the base. Okay? So let's pause there for a quick question. All right, we're back. So we have the formulas for perimeter, which aren't really formulas, right? Perimeter is just the fencing around a figure. The area formulas are a little trickier, but you notice for the three quadrilaterals, they're all the same, base times height. Remember, height has to form a right angle with the base. So how do you know which one the base is? The base is the side of the figure that the height forms a right angle with. So that might vary from person to person, depending on which side you choose for the base and the height, particularly with these two shapes. Same with the triangle. The height forms a right angle with the base, so wherever you see the height forming a right angle, that side is your base. Okay? Units for area. Let's throw those down here. So units for area, okay, are square units. Because remember, area is what is inside of a figure. Perimeter is the fence around a figure. Area is what's inside. So units for area are area squared, or I'm sorry, units for area are units squared. Because when we are finding perimeter, for instance, we're doing feet plus feet plus feet, or yards plus yards plus yards plus yards, or kilometers plus kilometers plus kilometers plus kilometers. Say that fast, very tricky. So when we're adding units together, it just stays the same unit. Feet plus feet plus feet is feet. Yards plus yards plus yards is yards. But when we're doing area, we'll be doing feet times feet, kilometers times kilometers, miles times miles. So when we multiply feet times feet or yards times yards, we are going to get square units. So feet squared, inches squared, yards squared, kilometers squared, centimeters squared, and so on. Okay? That is what I have on units. All right, so next, what I want to do is do some examples of these calculations. So let me come up with a few. There go my lights again. That's always fun, isn't it? I know I'm enjoying it. So let's do a few examples. So here is a quadrilateral. Okay, I'm going to make it a rectangle by making 4 right angles and making opposite sides congruent. Okay, so that's a rectangle. I'm going to call this side 6 inches, and I'm going to call this side 4 inches. Okay, So I'm going to pause the video right now and ask you to find the perimeter of that right now and ask you to find the perimeter of that rectangle. Okay, we're back. So the first thing I would say is, okay, we want to know how big the fence would have to be around this rectangle. So we have to add our four sides together. But I only gave you two sides. So how do you know what the missing sides would be? Well, you know from the congruence marks. These marks match. So if this is 6 inches, then this side would also have to be 6 inches, right? These congruence marks match. So if this side is 4 inches, this side would have to be 4 inches. So when you go to find the perimeter, use another color because I can. When you go to find the perimeter, you could either say to yourself, well, that's 4 plus 6 plus 4 plus 6 equals 20 inches. Make sure you include your units. Or you could have said, well, I know that's 4 times 2 plus 6 times 2, which is 8 plus 12, which is also 20 inches. Matters not to me how you get to that. This is probably a little more efficient, but who am I to judge? All right, I'm going to pause again and ask you to find the area of that rectangle. Okay, coming back, area is base times height for all three quadrilaterals we discussed. So how do you know what is the base and what is the height? We talked about that a little bit earlier. It doesn't matter because you could call the 4 the base and the 6 the height, or you could call the 6 the base and the 4 the height. They form a right angle with each other, so it's arbitrary which one you choose for the base and which one you choose for the height. And given what you know about the commutative property, does it matter if you say 4 times 6 or 6 times 4? Aren't you going to get the same result? And so remember, area is telling us how much space we have inside that rectangle, and 4 times 6 is 24 square inches. So if we wanted to build a fence around the rectangle, it would be a 20-inch fence. If we want to know how much space the rectangle holds, that would be 24 square inches. Okay? All right, moving on. Let us move on to a square. So a square, again, has the 4 right angles, and all 4 sides on this quadrilateral are the same, as is pointed out by the congruence marks. So in order for you to compute the perimeter and the area, I have to give you a measurement, right? So this time I'm going to call each of these sides, or one of these sides for now, how about 100? Okay, so I'm going to pause the video and ask you to find the perimeter of that square and make sure you include units in your answer. Okay, we are back. So to find the perimeter, which again is the amount of fence you would need to enclose this figure, I need to add the 4 sides together. Well, I only know one of the sides is 100, but since they all have the same congruence mark, I know that if one of the sides is 100, all of the sides are 100. And so when I go to find the perimeter, I can either say 100 plus 100 plus 100 plus 100, and you'll get kind of sick of doing that. And that's 400 units. You have to say units because I didn't give you a unit of measure. Okay, or you could say 4 times 100 is 400 units as well. All right, I'm going to pause the video and ask you to find the area of this square. Okay, we are back. Area is base times height, right? Just like with rectangles and parallelograms. The base and the height are going to be the same, right? 100. So with a square, you can say 100 times 100. If you want to be fancy, you could say 100 squared. Not going to save you a ton of time or ink or lead. So 100 times 100 would be a 1 followed by 4 zeros, right? So 10,000 square units Did you remember to put the units on? I forgot to remind you, but I hope you remember. All right, there's my whiteout, nice and handy, unlike my last video. I don't know why I have a square there. Just trying to show off with my whiteout, I guess. So this would also be, oh, I know why it's squared, because we said we could say it was 100 squared, which is 10,000 square units as well. Okay, so you shouldn't have needed a calculator for either of these or any of these computations, but if you are using a calculator, make sure you're using the one that you're going to be allowed to use on assessments. I can't stop you from using your phone, but on an assessment I can, and I hate to see you on an assessment having to learn how to use a calculator out of the blue. All right, let's finish up with parallelogram for the quadrilaterals, and then we will look at triangle for a moment. All right, remember, parallelogram is still base times height. It's a little trickier because we don't have the 4 built-in right angles. So we have to have a height given to us. Okay, how do we know it's a height? It has to have a right angle mark. If it doesn't have a right angle mark, then we don't know it's the height. That's really the only way we can know. Okay, so base times height, I have to give you those numbers. Now, you have to be careful because in some pictures, they're going to give you all kinds of information and you're not going to know which numbers to use. So this is not to scale, but let me call this number 2.7. And let's call these all centimeters. Okay, now I know these are the same because of the congruence marks. I know these are the same because of the congruence marks. So what happens is when you get going on a picture like this, first of all, let's find the perimeter because that will be easy, right? The fence part is always the easy part. So I'm going to pause the video. You find the perimeter of this parallelogram. Oh, and there go the lights. As I'm coming back, the perimeter, we add the 4 sides together because we're building a fence around the parallelogram. So we could say 3 plus 3 plus 5 plus 5, which would equal 16 centimeters. Or we could say that's 3 times 2 plus 5 times 2, which is 16 centimeters. Either way, that's the perimeter. For the area, remember, we have to do base times height for all 3 of the quadrilaterals that we are working on. And so this can get tricky. It's clear the height is 2.7, right? And that's the pink line. What people get messed up on here is which number is the base. Well, remember, the base is the side that the height forms a right angle with. So since the right angle is here, that means the base has to be 5 and not 3. 3 is irrelevant to area. So the area would be 5 times 2.7. Or 2.7 times 5. I don't really care which order you write those in, but you need to multiply those 2 together. And so when I multiply those together, I get 13.5 square centimeters. So make sure your units are correct. That's important. Perimeter is just plain old units. Area is square units. Okay? So that finishes up the 3 quadrilaterals. Let's move on to triangles. For some reason, triangles are tricky for people. And I think it's the formula because you have to divide by 2. So let me write down the formula. For all of these, it was area equals base times height. Okay? For the triangle, it's area equals base times height divided by 2. Okay? I like to say divided by 2. A lot of teachers will, and you've probably heard it this way, do 1/2 base times height. And I don't know why it is, but not just kids, pretty much everyone in the world finds it easier if I divide by 2 instead of multiplying by 1/2. Not sure why. I'm not here to question it. I'm just telling you what my 30 years of research has provided. So you may continue to use this formula if you like, or you can switch over to the easier version of base times height divided by 2. Are they different? Not at all. Dividing by 2 and multiplying by 1/2 are the exact same mathematical operation, and they render the same result. I am just here to tell you that people are more successful with this version. Take it or leave it. Okay, so let me label these sides for this triangle. I'm going to make it equilateral. And so I'm going to call each of these, let's say, 2 inches. Okay, so if this side is 2 inches, all 3 sides have to be 2 inches based on the congruence marks. So I'm going to pause the video and have you find the perimeter of this triangle. Okay, coming back, if all 3 sides are the same, they're all 2 inches, we do 2 plus 2 plus 2, or 2 times 3, or 3 times 2. They're all the same. Perimeter, 6 inches. Now, in order to find the area, you need more than just the sides. You need a height. We need base and a height, and we need to divide by 2. Now, one of these sides is going to be the base. In this case, all of the sides are the same, so we know the base is going to be 2. That won't always be the case. But in any event, I need to provide a height, so I am going to do that. Again, this picture will not be to scale. I'm going to make up a number for height, which is probably not mathematically correct, but I'm going to call the height, let's call it 1.6 inches. Okay? And so when I go to find the area, I would say the height is 1.6, the base is this side. Well, it just happens that all the sides are the same, but if the sides were all different, the base would be this side because that's where the right angle touches the triangle. Okay, so these are all 2. I'll go ahead and write that in. 2 times 1.6 divided by 2. Now you can crunch that into your calculator if you like, or if you're trying to become a stronger math student, you could notice that the 2's cancel. So some of you type into your calculator 2 times 1.6, right? And you would get 3.2. And now divide that by 2, and you will get 1.6. Or you could notice that these 2's cancel. And so that's 1.6 square inches. Okay, so you can type that into your calculator, you get 1.6. You can notice the 2's cancel, and you'll still get 1.6. Now, there won't always be something there that cancels, so I'm not completely discounting the use of calculators. I'm just saying that when you can cancel something, cancel it. It makes life a lot easier. Okay, so I'm going to do one more triangle for you, and then I'm going to let you go. So here's our triangle. Okay, poorly drawn, but I need a height because the formula for the area of a triangle says I need height, right? So I'm going to call the 3 sides on this triangle, let's say 12 feet. Let's call this one 9 feet, and we'll call this one 6 feet. Okay, and we're going to call this height, and again, just making these numbers up, let's do 10 feet, just to make our life easier. So I'm going to pause the video and ask you to find the perimeter of the triangle. Before I pause, I want to remind you, the triangle is the part drawn in purple. This pink part is just going to help us with other things. It's not part of the triangle. So everybody find the perimeter of this triangle. Okay, we're back. So perimeter is found by adding the 3 sides together of the triangle because we're trying to make a fence around this figure. So 12 plus 9 plus 6 equals 27 feet. okay? So you can write feet, or you can know that the single mark means feet. Now I'm going to pause the video and ask you to find area. Be careful when you're finding area. Remember, it's base times height divided by 2. And remember, the base has to be one of the sides of the triangle, okay? All right, there went my lights again to signal I should come back and help you. So the height of this triangle is pretty easy to see. That's 10. And the 10 forms a right angle with this side of the triangle. So that makes the base 6. Okay, so 6 is the base. The height is 10. And then we're going to divide by 2. Again, you could type in your calculator 6 times 10 divided by 2. And you would get 30 square feet. Or you could notice that this 2 could cancel either the 6 or the 10. Can do either one. I'm going to use it to cancel the 10, and 6 times 5 is also 30. Just if you're trying to become a stronger math student, you should cancel when you can. Less calculator use, the better. Again, you won't always see even numbers up here, but when you do, why not cancel the 2? All right, I'm going to ask you one more question, and then I'm going to call this video done for today. The question, which will show up in your Edpuzzle video in a second, is how do you feel about area and perimeter of these basic two-dimensional figures? Is there anything that I can help you with? What is troubling you? It might be the height, it might be finding the base, it might be the units. But please just don't say, I'm doing well. Just let me know what you're doing well on. Are you doing well with the units? Are you doing well with finding the base and the height? Are you doing well with knowing the formulas ahead of time? So be specific in your response. And I'm going to give you a couple of seconds to work on that. Okay, and we are back, and I wanted to say, remember, assessments are open notes, so make sure you're lucky. You don't have to memorize these formulas. But remember, you have to use an actual calculator on the assessment. So if you're using your phone or your computer right now, please get a scientific calculator. I mean, it doesn't need to be scientific for this learning target, but that's the type you should get if you're purchasing one. All right, you guys, I hope you have enjoyed Learning Target 0.2 as much as I have enjoyed delivering it. And I will see you soon for Learning Target 0.3.